Alright students, welcome to Chapter 9. In Chapter 9 we're going to introduce this whole idea of statistical significance, as well as the idea and calculations of confidence intervals. So the objectives for this chapter are to know what significance level is and statistical significance, and why these terms are important. And we'll also learn about the difference between type 1, which are also known as alpha, and type 2 errors, which is a beta error. We'll also learn about the plan for hypothesis testing. And so next week we're going to have our quiz. We're going to learn a little bit more about SPSS and inferential statistics. But really after this we're going to learn about all of the different types of hypothesis tests. And we're going to introduce this chapter, the plan that we're going to have when we do these different types of tests. And we're going to learn what type of test we're going to do given the scenario we're doing. We'll also learn the plan for hypothesis testing, and what type of tests we're going to run for a hypothesis test. And this really sets us up for what we're going to learn about after quiz 2 and learning about SPSS, which is really what type of test are we going to do if we're doing a difference test or if we're doing a relationship test. And then we'll learn what confidence intervals are and how we calculate and interpret them. Okay, so let's start with this idea of significance. And you may have seen this word a couple of times when we started talking about writing out our hypotheses. And really when we think about significance or statistical significance, this is really when we're trying to see, is there a difference between groups that is due to a systematic influence rather than chance? So we have a sample of people that we collect data from, because we don't really have access to the entire population. But really you want to see, okay, for example, men and women on heart disease. We want to see, does gender really have an influence on heart disease? Thinking about anything else that we know is a risk factor for heart disease, is gender in itself a risk factor for heart disease? So this idea of systematic influence is gender itself, and seeing if gender has a risk factor or has any influence on our dependent variable, which is heart disease. And really when we think about chance, well, we're going to have our sample of people, and if we see or we don't see that there is a difference, then really is that due to just chance, just the random fact that we pulled people from the population that may not really be representative of the entire population, and really just because of chance, just because of errors that may be introduced to our sample. So when we think about significance, we have to assume that all other factors that we think may contribute to our outcome are controlled for. So again, knowing that smoking, lack of exercise, a poor diet, all of these factors all contribute to heart disease. But we just want to know whether or not gender in itself has an influence on heart disease. So when we design a research study, we have to think about all these other possible factors that may contribute or may influence our outcome, our dependent variables, and collect data on that, so that when we run our statistical analyses, we can statistically control for all these other factors. Because the goal of research really, and trying to find significance, is to eliminate competing reasons for differences as much as possible. If we can say that gender really has its own influence, is its own risk factor for heart disease, taking into consideration that our sample of men and women smoke, don't exercise or do exercise, or don't eat healthy or do eat healthy, that since we know that all of these other risk factors contribute to heart disease, we need to control for these in our analyses to see whether or not gender is in itself a systematic influence to our outcome, which is heart disease. And so when we think about significance and significance levels, we can really set our own significance level, and this is what we call alpha. And so the significance level is the risk associated with not being 100% positive or 100% sure that what occurred in your experiment or in your research study is a result of what you did or of what is really being tested. We're looking to see whether or not there's differences between men and women on heart disease. Well, we're not going to be 100% sure and 100% positive of our results. So we need to say, okay, given that we don't know the true nature of what it is that we're studying because we are not really studying the population, we have to give ourselves a certain amount of risk of being wrong. And this is what we say is our significance level. At what level are you saying, I'm willing to say that I'm so much percent wrong when you accept or you reject your hypotheses? And so when we run the analyses, we have our statistical significance. We have a number that we get, which is called a p-value. And our p-value is the degree of risk that you're willing to take that you will reject the null hypothesis when in fact it really is true. If there really are no differences in the population between men and women on heart disease, our p-value, our statistical significance, is the degree that we're willing to say, you know what, really do see differences, when really in fact there really are no differences. And so we'll talk much more in detail about alpha and p-value in the coming slides. And so when you conduct research and you do these experiments, you're going to get a p-value. And that p-value will tell you whether or not you have statistical significance. And if you have statistical significance, it doesn't necessarily mean that there is meaningfulness. So let's take a different example. Let's say we're thinking about giving a new intervention on weight loss. And we see in this sample of 5,000 men and women, we see that they lost on average 0.2 of a pound. So 0.2 pounds of weight loss. Well, when we do our research and we run our analyses and we find that that loss of 0.2 of a pound is statistically significant, well, does that really mean much to somebody who's trying to lose weight and is maybe 50 pounds overweight, maybe 100 pounds overweight? Does 0.2 pounds really mean anything? No, it doesn't. So while a study may be statistically significant, it may not necessarily be meaningful. Also, the thing about statistical significance, so we can really only interpret the results of your study only within the context of which it occurred. And so what I mean by this is you have to think about, does my sample look like the population? And the more that my sample looks like the population and is more representative of the population, then I can have more inferences. But a lot of the time, because of funding, because of geography, because of time, our sample doesn't always really look like the population. And so really, we have to think about the context in which it occurred, the geography, or sample characteristics, and think about, okay, what are the limitations of my study and my experiment in terms of trying to infer these results to the larger population? And so thinking about all of this, statistical significance, or trying to reach statistical significance, should not be the only goal of scientific research. Many researchers strive to get significance. And on the other side, a lot of publications and a lot of editors and journals choose not to publish insignificant research, or research that did not find a statistical significance, a significant difference between groups, or significant relationships. But I think that's also important as well. If we're trying to see if there are differences between groups and a certain outcome, or looking to see if there are relationships between certain variables, well, don't you think it'd be just as important to see if there really are differences, or if there are relationships, if there really are no differences or no relationships? And so a lot of researchers and a lot of journals and editors always tend to really weigh this whole idea of statistical significance. But there's this shift, this very slow, and I would say very resistant shift, of trying to stay away and shift away from this whole idea of statistical significance. And the last thing about significance. It's really influenced by your sample size. The bigger the sample size, the smaller the sample size, we'll see how that influences whether or not you find statistical significance or not. Is it easier to find statistical significance in a sample of 5 people compared to a sample of 5,000 people? Yes, there is, and we'll see much more about this later.